Hello, everyone. Welcome to our webinar. My name is Ahmed Zamir. I'm going to be the moderator for this webinar today. Hello, everyone. Welcome to our webinar. The title of our presentation today is Say Bye to Refactoring While Moving to Multi-Cloud App Delivery. My name is Ahmed Zamir. I am the moderator for this webinar this morning or today. I have with me Sally Moore, who is a solution architect that will be able to help us present the salient points here, as well as Rahul Padki, who is a senior product line manager covering AVI advanced load balancing solutions. Let me start by doing some administrative things. Please provide us with questions, any questions that you have on your mind, and put them in the question area. We will answer those questions towards the end, as well as any questions that may come later. This solution or this presentation really covers an important area, since we are more or less in a multi-cloud environment, mostly in most organizations. That delivers larger quantities of data and requires handling or delicate handling of the load balancing between the multiple cloud instances and so forth. At the same time, when people talk about clouds, oftentimes they forget to mention the fact that people or organizations and enterprises buy IT solutions because they want to run their applications. And that is the core concept that we want to talk about today, is the importance of app delivery, balancing the traffic between them, and how can we help you realize the goals that you established your environment in the best way, in a secure, then agile, and high performance way. I'm going to transfer the conversation to Sally so she can, to Rahul, so he can start the presentation for us. Rahul, it's all yours.
Thanks, Ahmed. Hello, everyone. Good morning, good afternoon, good evening. I'm Rahul, and I'll be covering today part of the agenda where we'll look at sort of the excitement and the strategy that most companies have to go multi-cloud for various reasons. Then we'll look at some of the challenges that brings in, and that essentially creates a need for really creating a easy to consume flexible interface to really provide the agility to our customers. We'll then look at how VMware NSX Advanced Load Balancer, also known as AVI, helps to solve some of these challenges. We'll look at use cases and validated solutions, followed by a product demo, and we'll then have Q&A at the end. Sally, so if you could move to the next slide, please. So if we look at some of the challenges, some of the motivations for customers to move into multi-cloud, as we've seen, most customers that we speak to, also through reports from the State of Cloud that have come out, show that majority of enterprises have a multi-cloud, hybrid cloud in their planning, as well as execution. Almost every single enterprise is becoming a hybrid cloud enterprise, and there are good reasons for that. Different clouds provide different innovations and excellence in different areas, maybe machine learning, maybe enterprise software, maybe secure services, etc. And for those reasons, and then when you think of marrying those reasons with, you want companies always want to build developer-friendly infrastructure. They want to deploy applications as soon as they can, and of course, they want to spread it out closer to their customers, and therefore, edge deployments are becoming more and more powerful and popular. And of course, there is this whole cross-platform replatforming that's being done for applications, where they're moving, some of the applications are moving from being hosted within VMs to actually being either hosted as containers or being re-architected in the whole Kubernetes ecosystem. So all of this creates a lot of flux, but this really, the intent of all of this is to create something that is consistent across the board and should allow flexibility. And with that, companies aim to keep their developers highly performant, which enables them to deliver applications with agility, and through that they will drive their business growth. That's really the goal to becoming hybrid. It's not something that our customers look at just for the heck of doing it. It's really to serve the business needs end of the day, to create something that is consistent, flexible, which allows them to enable rapid innovation. Sally, can you go to the next slide? With this, what we've seen is, even though the stated goal and agenda is to really enable this rapid innovation, but hybrid cloud is a complicated space. Different hyperscalers, different on-premise providers have their own abstraction and have their own interfaces of defining how an application gets hosted, deployed, architected, and operationalized. And this creates challenges in a few ways. One, your applications and your data are really siloed. So how do you connect them in an abstract fashion so that it becomes easy to not only deploy at day zero, but also to continuously manage them across the life cycle of your application. Maybe you start today as a single region application servicing only your North America customers, but then soon enough, it becomes a global application that is servicing your customers across the world. And now you need to think about multi-region, you need to think about potentially multi-cloud because of any governance issues, etc. The use cases might be manifold, but the problem remains the same. How do you take an application global across disparate ecosystems? To do that, we've seen very often that there is a lack of end-to-end automation that really helps customers and simplifies their journey to deploy these applications, where customers don't have to script every little bit to deploy their app, but rather the platform that they are choosing helps them to take some of those decisions, offload some of those decisions, and automate bulk of the effort for them out of the box. And of course, hybrid cloud is a complicated space, and visibility is of utmost concern. Getting client traces, getting insights into how clients are experiencing applications, very vital. And of course, costs are always a high concern. And if you're thinking of going multi-cloud, and as a resultant of that, if companies have to re-architect, re-platform, and retool their ops teams, it's always going to be an expensive affair. So what we've seen is these are some of the challenges that our customers are regularly grappling with. And one of the points that I want to highlight before we jump into the meat of the talk is, Sally, if you can move to the next slide, is really this concept of providing a abstraction interface that's truly multi-cloud, which sort of stretches across all of your public cloud as well as on-premise and everything in between. And this API abstraction really is something of a powerhouse, where when users want to deploy an application, users would simply need to convey the intent of the application, such as, I want to deploy an application in my AWS US West region. What happens thereafter is all taken care of by that abstraction layer in the product, which is to create the necessary instances, to program networking, to program security, and after that deploy the application. For that application, then figure out what IP address schema is required by integrating with IPAMs that customers are using, integrating with DNS services that customers are using, and then ultimately providing certificate management for that application. And doing this not only day zero, let's say you started with AWS, but tomorrow you want to take that application and deploy it in Azure, the same level of abstraction, that intent layer remains consistent, that enables you to really take your application, take any application and really take it to any cloud and provide a single consistent abstraction interface. And Avi prides itself in being a thought leader in the application delivery space, where we have a rich cloud connector platform that really helps customers navigate this hybrid cloud world, where whilst providing a consistent abstraction interface that makes both consumption as well as operationalization of your applications in this hybrid world a lot more easier. So with that, let me pass the baton to Saili, who would share more details about the platform and what we do.
So I'm going to talk about the architecture of Avi and how we are different and how we disrupted the load balancer architecture, right? So what Avi has done is, I'm sorry. Okay, we have separated the control plane from the data plane. So there are two components here, the Avi controller and the service engines. These service engines are the actual load balancers, right? The Avi controller will sit in the control plane, and the service engines will sit in the data plane. Now the controller, it's the brain of the system. So this is the single REST API endpoint, and this is where your configuration is done. This is where your policies reside. The CI and the ULI are built on top of that. So we are all REST API, we are all software, right? Because of that, it can be deployed in any environment. Now, the service engines, they are stateless. They are elastic. The Avi controller will manage the entire life cycle of these service engines. What that means is the controller will spin them up, it will spin them down, it will scale them in and scale them out based on your requirements. So you can go from anywhere from like a one service engine or one load balancer to 100 within the span of few minutes, but it actually doesn't change anything for you. So you don't have the extra overhead of configuring those hundreds of load balancers. Avi takes care of all of that, the controller. Now, what if the Avi controller dies? What happens then? Because of that separation of control and data plane, your traffic will not be affected. Your traffic continues to flow as is while we work on your controller. What if your service engine or your load balancers are in a failure state? Now, because of our automation controller, the Avi controller will detect this failure. It will self-heal the service engine. So it will spin up a new service engine and you will be right back at the capacity you want to be at. Right, so our fabric will increase and decrease based on your requirements. So we can be, like I said earlier, we can be deployed anywhere. So for example, the service engines can be on-prem, be in a bare metal, virtualized or container form. It can be in a container environment or in public clouds. Now you don't have to have Avi controller in all these environments. Your controller can reside in just one ecosystem. So let's say my controller is on-prem VMware vCenter environment, but my service engines are load balancing applications which are in that VMware environment as well as in public cloud environment. And all we have to do is the cloud connector piece that Rahul just talked about a slide ago, right? Because of our API abstraction, it makes it super easy. We just have to tell the application our intent, where we want it to be deployed. and Avi takes care of all of it behind the scenes. So let me just pull this slide up. So because of this kind of architecture, we are giving that centralized automation, right? We are all REST API based, so we work well with Terraform, Ansible, not just decision automation, but also infrastructure automation. Now, while the service engines are load balancing or passing on the traffic, they also collect all that telemetry data and pass it on to the controller. Now, the controller will display that information on a dashboard in a very human readable format, right? So we display analytics like concurrent connections, throughput, all of that, which is normal, but also end-to-end timing for every connection. And I have never seen this before in any other solution, right? Previously, I've spent hours or days troubleshooting an issue to find out where the latency is. Is it the app traffic? Is this because of the application? Is it because of the network? Where is that latency? What are the end-to-end timings? I've done tens and thousands of packet captures at 10 different points: the ingress of the VM, the ingress of the hosts, the ingress of the vCenter, the egress points. But Avi, because of the way it's laid out, it makes it easier. You get end-to-end timings at every point displayed for you. So we have taken out that packet capture. You don't have to do packet capture to find out what's going on in your environment. And I will show all of this in the demo. We also have a Pulse service, which is the cloud service platform. So we provide bot management, we do centralized licensing, proactive support cases. We provide hosted controllers. By hosted controllers, what I mean is Avi's team will take care of the controllers, and you are in charge of your workload environment. So we have made it super easy for you to manage and provide applications. So let's take a look at some of the use cases. Avi is one solution that can be deployed anywhere, be it an on-prem environment, be it public clouds, be it containers, be it the EUC end user computing space, right? We have, even within the VMware portfolio, we have deep integrations with NSX, VCF, public clouds, the Horizon and Workspace portfolio, the Tanzu portfolio, right? From a functional standpoint, Avi provides all the load balancing capabilities that you would see in a traditional load balancer, like caching, content switching, local load balancing, traffic management. From a security point, we also do web application firewalling, bot management, SSL encryption, decryption, all of that on top of GSLD, which is the global traffic management. So for example, if you have two environments in two different geolocations, we make it easier for you to route the traffic based on those geolocations or whatever algorithm is preferred for that application. I want to talk about, WAF a bit, web application firewall, before I move forward. Okay? So while talking to a lot of customers now, what we have observed is web application firewall is not deployed by many of them. And the common reasons that we found is one, well, it's very complex to deploy. And if we do something, a misconfiguration, or and the traffic is blocked, there is no way for them to know why that traffic is blocked, because it's opaque. The second reason that came forward was, well, WAF uses a lot of CPU. It's a CPU intensive process, and in times of our peak application access, and if we have WAF enabled, there is no way for us to scale out, and it affects the usage of our application, right? Because it's in just one box. Now, because we provide the auto scalable or scale out architecture and rich visibility, we overcome these challenges. So WAF deployment makes it, we have made it super easy with our architecture. Now, I wanted to shed some light on, now I've talked a lot about how we can be deployed in, how our service engines can be deployed in all different environments. So let's take a look at how that abstraction happens, right? I'm going to talk about public clouds first. So let's take an example of AWS. So how does that process work? So what we have to do for that cloud connector configuration is when you deploy RV controller, it can be deployed from AWS Marketspace too. When that graphical user interface is up, we deploy AWS Cloud Connector by giving AWS credentials. Once that API is made, we give other information like what VPC we want our workloads are in, or what VPC we want our service engines to be, what network, is it a single AZ or a multi-AZ application, right? We give all those information. Once that process of cloud connector configuration is completed, which only take a couple of minutes, an AMI image is created. Now this AMI image is put in your Amazon S3 buckets. Now we require this image to deploy the service engines. So whenever you go ahead and create a virtual service or a VIP by giving IP addresses and whatnot, what happens in the background is the controller will scan if there are any existing service engines already deployed. If there are service engines already deployed, it will see which service engine has enough resources to put this virtual service on, and it will make that decision. Right? You will not have to tell the controller what to do or where to put the service engine on. Now, in cases where this is a new deployment, there are no service engines. What happens is the controller will realize this, there are no service engines, and it will create a new service engine from that AMI image that was created in the first step. And once that service engine is deployed, it will have two ENIs, so one for management and then one for data traffic. And that's it. And your virtual service is up and you're load balancing your traffic. This process of creating cloud connector remains the same in any environment, be it AWS, be it Azure, be it Google Cloud, be it VMware or NSX or OpenStack, any of it, right? So let's take a look at, so in Azure, again, same process. All we have to do is once that RV controller is up, you tell the controller where to go to fetch information about Google Cloud. Or Microsoft Cloud. We also support RV in VCF environments. We have a VMware validated solution out, so it makes it easier for you to go through the process of seeing what kind of applications I'm using, what deployment I have, and deploy RV with VCF with that validated design. Now, because we are all REST API based, we integrate very well with all the automation tools. So we integrated VRA. We can use Ansible playbooks for that end-to-end automation, Terraform modules. We have customers from the financial verticals to healthcare verticals who have thousands of applications. And creating this manually is to avoid that hassle. We have made it easier to use playbooks. Now, we can also have that one-on-one conversation per use case and per design, and make it easier if you need some custom built automation, right? Now, if there is a migration in place, we already have migration tool in our controller. So we have made it very easy for the migration as well. Is nothing manual, everything is automated. Now, with that, I want to move on to the demo, and we'll have enough time for Q&As at the end. So let me stop sharing this. Okay, so once you log in, this is the first screen that you see. This is your default screen. And what this shows is all your virtual services, all your applications. And as you can see, I have my applications, my VIPs in AWS, Azure, some of them are on VMware environment. So it's different cloud connectors hosting different applications, virtual services. So first thing that you will have to do when your controller is up that I talked about is configure that cloud connector. So let's take a look at how we do that. So you get to infrastructure and clouds. And as you can see, I have an AWS cloud, I have an Azure cloud, a VMware cloud. So different environments configured on one controller, right? So the way you have to do is give it a name. You give it what region you want this to be deployed in. You provide AWS credentials. So it can be a secret access key, or it can also be IAM roles. And you can also use Amazon Route 53 here to configure your A records or place your A records. Now let's take a look at VMware Cloud. For VMware, I'm doing the same thing. I've given it a name. I'm giving the username and password and credentials, my vCenter access. I'm providing my IPAM profiles, my data center. Once you provide those credentials, it will pull all the information based on that environment, and you can just select which environment, which data center, or which networks you want this to be placed on. So it will just pull all the environments, all the networks or subnets that you have, and you select which one I want for my SE management, what's my IP subnet, etc., etc. So once this cloud configuration is done, let's go back to our application view. So this is your dashboard for all your virtual services. And the first thing you might see is, oh, these are all different colors, and there's a number associated with every virtual service. What this number is, it's a score, a health score. Now, we give it a health score based on different things. First is performance. Now, what we consider under performance is ease of use. How easy it is for your user, your end user, to access this application. Are there any TCP retransmit? If there's a retransmit, that would deduct your score. We consider resource penalty. Resource penalty is a negative score, so it will calculate all the underlying resource usage. So how's the CPU, how's the memory? All of that is considered under resource penalty. Anomaly penalty is, it detects any change in behavior. So let's say, for example, every day from 9 a.m. to 11 a.m., I have very low traffic, no traffic, very minimal traffic. And then one fine day, the traffic hits to the roof. That is a change in behavior. That is an anomaly. So that will give you a negative score. Now, if you know that there is some activity that's going to happen, you can customize that profile. So everything that you see here is customizable. Under security penalty, we consider SSL certificate expiry or DDoS. So let's say I have a SSL expiry coming up. So it will notify you, but will also give you a negative score. Now the total health score is the performance score minus all these penalties. So we have made it easier for you, one pane of glass, to look all your applications at one go and see what's happening with any of your applications. Right? So you don't have to drill down all of your environments, right? It's just one single pane of glass. Now, this is just a list view. What if I want to find out what the logical view looks like? So you go here on the top and do a tree view. Now, I like this view because it gives me a logical explanation of what this application looks like. These are my backend pool members. These are my pools, and these are my pool members. On the bottom, you will see these two green boxes. These are my service engines, so the actual load balancers, right? And so if I want to find out where is my AWS app sitting on which service engine, you just do a drop down and you find out, okay, this is the service engine that is hosting my virtual service or my web. The other thing I would like to mention is you can do tenancy. So we work very well with MSP programs because we can do different tenants. Currently, I'm in the demo tenant. Now let's take a look at the logs. So these are the analytics and logs that I was talking about. We display logs or information going back to a year. And you can offload this to any of your syslog server, be it Splunk or Grafana, in any of your syslog server, basically. You can drop down or customize the time frame that you want to take a look of how your traffic, how your application was doing in that time frame. Under logs, we notify or display every connection that is coming to this virtual service. So let's take a look at one of this connection. Okay, so this is my client, and my client took 42 milliseconds to reach the load balancer, 1 millisecond to the server. It took 96 milliseconds for the application response, and a total of 139 milliseconds. Now, so if you're having reports about application delays or not able to access the virtual service, you come here in the logs and you can easily find out, okay, my application is taking way too much. There's something going on with my application. So let's go take a look at that server. It's easier to find out by this end-to-end timing log. Now, on top of this, you also get information about your clients. Okay, what is my client IP? Where is my client coming from? So this is my client IP. It's coming on this port from Japan. He's using an iOS operating system from an iPad and using a Safari browser. My SSL version is 1.2. This is the kind of certificate it's using. So a bunch of information for the client. So this information is also useful for app owners if they want to come up with a new release, a new version of the application. All this information regarding the client usage, the location, the geolocation targets, the iOS devices, all that information comes in handy. In the middle section, you will see information on what service engine is load balancing this traffic, what the app response time looks like, which server it's going to, what's the backend server looks like. And every blue line that you see here acts as a filter. So if I want to see my app response, which is greater than or equal to 96 milliseconds, I just add that filter and it will display all that information. On the right-hand side, you can also use these as filters. So if I want to see, okay, 96 milliseconds and more, all the responses are displayed, but which server is responsible for this? So I just go to server IP address, and immediately I know all the delays are coming from this .202 server. So we go to that box and see what's going on. Again, we have a time frame that goes back all the way to a year or all time, and then you can offload it to your syslog server. The next thing I would like to, now on top of that, if you still want to do like a packet capture, we still have that option available. So you go to operations, traffic capture. And again, this we have made it very easy. You don't have to scramble and come up with 10 different commands, because I've done this before. I know how hard it is. You have to come with 10 different packet capture commands, copy paste, start the timer, stop the timer, download it. No, we have made it very easy. You go here, edit, and select the virtual service that you want to do a capture on. So I'm going to do AVI demo. You have the option to select a filter. Right? You can do all traffic or a certain client IP. I'm doing 1 minute, packet size, and I only want the data traffic. I don't want health monitor traffic. And you start the capture. Now, once the capture is ready, and you can see it here, the file will be available here in the completed capture section for downloading. We also, now this happened yesterday, so it's very fresh in my mind. We log all the events that happen with the controller, or what the controller is doing, what the service engines are doing. So let's take a look at that. Okay. So it logs all the events for all virtual service, and we have the option to include internal processes, that what's going on with the internal processes. So for example, yesterday I had a customer call in to say, hey, I'm trying to deploy a virtual service, but the service engine is not coming up. And I just gave, and because the service engine is not up yet, there are no logs in the log section. So how do I find out? I came here in the event section, and immediately the top line said, oh, the service engine cannot come up because it's not getting an IP. So within a minute, I was able to, we were able to identify the problem. There were not enough IP addresses available. So it was an easy fix. So apart from logs and the easy traffic capture, you also have this event section to help you to understand what's going on with your environment. We have the option to alert, set alerts, and give out notifications, and automate all of that as well. Let's take a look at administration here. So under administration, you can create any granular roles. So I want my app owner to see what's going on in the with the traffic, like what's the client base, where are they coming from. So I want him to have access just to the log board, but not GSLB, right? Not any profile. So I can create those granular roles here. The network admin can only have access to applications or profiles, but nothing to do with the main administration sort of accounts. We can create and configure any kinds of or design any roles that we want here. We have the tenant option that I mentioned earlier. We can have different tenants. Now, here I have just one controller, but in production environments, we recommend having a cluster of 3 for AVI controllers. And we have also made the upgrade process very easy. I know how painful it is for upgrades. So what we've done is when you start upgrading the controller, it will create a partition and do the upgrade and auto reboot. Now, if during that reboot, if there is any mismatch in the versions, if it senses any problem, it will auto roll back to the previous version. So it doesn't affect any of your data traffic because it's all happening in the control plane. Now, what if you want to upgrade your service engines, right? We have made that easy too. So we have the option of creating different service engine groups, right? So what that means is I can have a group of service engines dedicated for just my Avi demo or one of the applications. I have my service engines for, let's say, one business unit. I have another service engine group for, let's say, just HR or just a finance group. So you can plan and manage upgrades based on that service engine group, so others will not be affected. So with that, let me think if I can think of, GSLV services. So if you can see here, I have 5 different controllers in 5 different locations, which are geologically separated, right? And I'm using GSLV services to have that easy customer use case, so user experience. So the way to configure that is you go to GSLV, and the GSLV configuration is only done from your leader controller. So you will have to do it just once, and it will be populated to other controllers. So what we do on the leader controller, which is my Tokyo, let me log in here. Infrastructure. All we have to do is provide the IP address and user credentials for the controller, which is sitting in a different geologically separated area, right? So for example, for San Francisco, I'm giving the username password. I am giving the latitude and longitude. So if the traffic is coming from these locations, route them to San Francisco controller, and so on and so forth. So we have made that easy to configure GSLV services too. So with that, I think we can move to Q&A. Let me bring my slide back.
So hi, everybody. First of all, thank you, Rahul and Sally, for that great presentation. I think we have a few questions. The first one, questions from the audience. The first one will go to Rahul. It says, when you are saying migration is automated, I would like to understand how it stands between hybrid cloud scenarios, basically how it would work in hybrid cloud scenarios. Rahul.
Amit, could you repeat that question again, please?
Sure. It says, it's addressed to the presenter. When you are saying migration is automated, basically, the member of the audience would like to understand how that works between hybrid clouds.
Absolutely. So I'd like to tackle that question in a few ways. One is essentially migrating your load balancing assets coming in from sort of other vendors, F5s of the world, NetScalers of the world, even NSX TLB for that matter. If you're coming in from any of those platforms, then we have migration tooling available that will help take your assets from those load balancing vendors over to the NSX ALB/AVI platform. Now with that, actually there are a couple of great PSO promos that are happening right now where you can engage with us. I'm just giving a email alias that you can reach out to, and you could reach out to that email alias, and we'll get you connected with one of our sellers. One of the program that's available right now is for qualified customers. We are offering free PSO credits to help get your load balancing assets migrated over to AVI. So that's one. Second part is, if you're already on the AVI platform, then by nature of the solution, AVI is already a multi-tenant, multi-cloud solution, like Sally showed. And through that, if you, let's say you want to take your application that is deployed on-prem and you want to take it to cloud, there are a couple of ways that you can do it. One, if you want essentially to have a multi-cloud deployment for your application, or if you want to enable use cases such as cloud bursting, etc., then you can actually deploy using the same control plane. You can deploy a new application in AWS with the same abstraction interface, and you can stitch that all up using GSLB. If on the other side, if you want to take the application that you've already deployed on-prem and take it to the cloud, then because Avi has these cloud connector abstractions, most of your policies that you've created for the application remain the same, and there is a very easy way that you can essentially clone a virtual service from a cloud. In this case, it might be a vCenter cloud, and you can clone it to be applied to a AWS cloud. So all of those scenarios are fully supported, and depending on your use case, we can definitely discuss more.
Thank you. We have a question from the audience for Saleh. It says, how would moving to NSX advanced load balancing, the Avi solution, may impact my currently deployed cloud applications, if it has an impact? Saleh?
Yep. Can you please repeat that?
Sure. It says, how would moving to Avi advanced load balancing may impact my currently deployed cloud applications?
So we, again, like Ross mentioned, we can do one-on-one use cases and discuss more, but there are a bunch of things we can have. We can bring up that application in Avi and use GSLB to just do that switch to route the traffic to a different IP or a different FQDN, or keeping the same FQDN using DNS-based load balancing. So we can do that cutover.
Okay, so no impact that we can discern.
Yeah, but it depends on also the application. So we can discuss more on what kind of application that you have and all of that. Yep.
Excellent.
Yes, and I'd like to add to that, Ahmed. Avi is deployed natively in all public clouds, including on-prem, right? With that, because it's automated end-to-end in public clouds, not only the infrastructure setup, but also the images get uploaded in an encrypted fashion. Your key management is all secret. All of that is done in a native public cloud way. And because the fact that the platform provides automation end-to-end, standing up infrastructure for after your initial VMs, which is a couple of minutes, after that it just takes seconds to program your application. So once, if you're looking at a cutover time, the cutover from our cutover from legacy LBs over to Avi is done in a matter of seconds. Now, of course, during the change window, there's of course going to be, when you decide to cut over the traffic, if it's not a DNS flip, then there might be a small blip for the application. But because the automation prowess that Avi has, the effective cutover downtime for the application is mere is essentially measured in seconds, not minutes or hours, etc. So it's extremely easy to insert Avi and essentially drain traffic from your old load balancers, legacy load balancers, over to the Avi platform. And of course, if you're doing something using DNS, then effective downtime is 0, because you're just doing DNS traffic engineering and diverting traffic over onto the Avi side, away from the legacy load balancers. So those are the two patterns that customers typically follow.
Okay, excellent. So one more question that either one of you can answer. It says that we already, or our company already, uses VMware NSXT. How could we take advantage of the advanced features of the Avi solution? Basically, they're probably asking, do they upgrade, migrate, whatever? Either one of you could answer the question. Thank you.
That's a great question. I can take that question, Ahmed. That's a great question. We get this all the time. So for customers who are using NSX-TLB, there are two options with respect to Avi. One is if you are using NSX-TLB, you are entitled to get an edition of Avi called Avi Basic at no cost. That edition allows you to basically, it is feature equivalence with NSX-TLB. You can deploy load balancing in your NSX-T environment. It's limited to NSX-T environment, so no hybrid cloud. You can't do AWS, you can't do Azure, etc. But you can deploy on NSX-T ecosystems with the feature equivalence, the same level of visibility that NSX-T offers. So some of the visibility aspects that Saili mentioned, those wouldn't be available in Avi Basic. But apart from that, the functionality wise, it's going to be 1:1 with what NSX-TLB offers. And then for customers who want to essentially utilize a broader feature set, maybe you want to deploy WAF, maybe you want to deploy some HTTP2, advanced SSL, etc., active Elastic Fabric, you want analytics, you want multi-cloud, all of those features are available with Avi Enterprise. And that's available for NSX customers at a extra discounted price over customers who don't have NSX-T entitlements. So two options: NSX-TLB equivalent feature sets available through Avi Basic at no extra cost, and a standalone Avi Enterprise purchase available at a discounted price. This discount applies over all of the other discounts that you would be getting through VMware.
Thank you. Very good answer. One more question. The user is saying that we already have appliance or legacy appliance load balancers. When I deploy Avi solution, do I have to replace those appliances, or can I deploy Avi solution on certain apps and leave others running on the legacy environment?
Yeah, absolutely, Amit. The latter. You could do a side-by-side deployment, and you can cut over one app at a time, and that's really what most of our customers do. They typically pick applications that they want to migrate. They do the config cutover first. They make sure that the config looks kosher. Then they do some sanity testing of the application hosted on Avi, and only then they go and do a cutover. And the migration tools that I spoke about, these are open source, freely available. Customers can, of course, try them on their own, but if they need help, VMware PSO is always ready to help with those toolings to get migration going. Most of our customers coming in from legacy load balancing like F5, Citrix, etc., are using these tools to come over to Avi, and they use these tools to really help navigate and orchestrate their migrations. And most of them do it, if not per app, at least a batch of apps at a time. So that's completely possible.
Okay, that is excellent. So thank you both for your very informative presentation. We all learned that when you deploy Avi advanced load balancing solutions, you can gain the benefits of unified app delivery. You will be able to automate deployment and reviewing your environment. You gain more visibility or complete visibility of the environment, which allows you to deal with abnormal situations. And finally, of course, one thing that everybody looks for, deployments of Avi load balancing would allow companies to optimize their cloud costs, which is a big thing today. So with that, I want to thank everybody for joining us today, and we look forward to seeing you in another webinar. Thank you. Have a great day.
Thank you.